Morning everyone. So today, just a little video of how we can find the equation of a straight line between two given points. And this is stepping it up from what we had last time. We're not using the idea that we have the actual intercept. We are going to use the idea that we don't have that intercept and just use two separate points. And we're going to do this via two methods. The first method is going to be using the normal formula that you've seen before, y equals mx plus c. And the second method is going to be where you're using a different formula, which we're going to talk about in a minute. So first things first, I'd just like to have a sketch on the side as a general indication of where my points are. So that point there is minus 1, 7. And then my point A is approximately over here. It just leaves me an approximate value, approximate position. But the real reason why we do it is the fact that we now know, generally speaking, that our line is going to have a negative gradient. And we can actually work out the gradient by just using the diagram. So we know that it goes across from minus 1 on the x-axis across to 4 on the x-axis. That means it's 5 going across. And it goes from 7 on the y down to 3. So that's going to be negative 4. So the gradient straight away for this graph is negative 4/5. So that's our starting point, okay? Now, in terms of a method of how to work out our straight line equation, we're going to have two situations. We can either use the old faithful y equals mx plus c, which is all where we use the idea of our gradient and intercept. And I know we don't have the intercept, but I'll show you how to use that. Or we use a newer method, which is what I introduced you to yesterday, which is this: y minus y1 is equal to mx minus x1. Okay, so how do we use the y equals mx plus c? Well, we've got our m already from up the top here. We've got minus 4/5. In this case, what we need to do now is we need to then use this formula. Now, to use this formula, all we need is we need the m, and we need 1 point, which we do have. And it doesn't matter which point we use, but we use one of those points, okay? It might be useful just to use point A, just because it doesn't have any negatives in there, just to save us a bit of pain later on. So our first port of call then is to substitute it in. So we know for a while that using point A, so I'm going to substitute in 4, 3. Using point A, we're going to get 3 equals minus 4/5 times 4 plus c. And we're going to now work out what c is going to be. To work out what c is going to be, we can do something a little bit easy for ourselves. We can either times everything by 4. Let's just say times the minus 4/5 by 4. But what's easier is to get rid of this 5 by multiplying everything by 5. So we can go and multiply everything by 5 and get us, so I'm just going to put multiply by 5 on there, which will then get us 15 equals minus 4 times 4 plus 5c. And the only thing you've got to bear in mind with doing that method is that everything gets times by 5 every single term. By the time we get to that, we then just need to now do a nice simple algebra equation. We need to move the minus 16 on the other side. So to move the minus 16 on the other side, we obviously have to add 16 to both sides. So we get 31 is equal to 5c. So c becomes 31 over 5. The only problem with this method is not only is there are lots of steps, we then have to, at the end, write a final answer and say, therefore, the line is equal to y is equal to minus 4/5 x plus 31 over 5. Now that's in true intercept form, and if you have a look at the intercept 31 divided by 5, it's approximately it's approximately, oh, sorry, I've got my there. It's going to be approximately 5 into 31 is 6 1/5. So it's going to be about 6.2. If you go back up to the diagram we had a minute ago, it's got to be between 7 and 3. It doesn't necessarily have to be in the middle, but it does have to be fairly, definitely in the middle, in between the two values. So in this case, that kind of makes sense. The other way we can write our equation is the fact that we don't always have to write it in the y equals form. We can times everything by 5. That's the same. That is the same. This is also the same. So if we move the 4x onto the left-hand side, this is also the same. So they are all equivalent to each other. Okay? So they're all equivalent to each other. Now, depending on what the question asks you, obviously, is you can write it in any of those forms. Okay? So that's the first method. The second method is where we use a slightly different formula. And the different formula is this one here. Now, this one allows us to go through the whole process, but in this case, it's going to be a bit easier because the fact that we still only need 1 point, which we have. Okay, so we still need everything like we had last time. However, what we're going to do is the fact that once we've put the values in, we technically have an acceptable straight line. Whereas before, we had to work out a value of c. So what I mean by that is this. So if I substitute in my point, so I'm going to substitute in 4, 3 again, exactly the same. Then what happens is this. We then assign the 4 as being our x1 and the 3 as being our y1. And we go ahead and substitute everything in that we know. So we go y minus 3 is equal to minus 4/5 x minus 4. At this stage, technically speaking, that is an acceptable and correct straight line graph. Whereas this one here, when we was working with the y equals mx plus c, we still have to do all these steps to work out c. This is technically an acceptable form of a straight line equation. But we do want to try and sort it out a little bit more. So the best bit, again, as normal, is to times everything by 5, just to make it easy on ourselves. So if we times everything by 5, every single term gets times by 5. 5y minus 15 is equal to minus 4 brackets x minus 4. You'll notice that all I've done is I've not times the x and the 4 because at the moment in time we're just timesing that fraction, so that's something to bear in mind. If we expand the bracket, so by timesing everything by minus 4, and if we collect our like terms, so we move the 15, so let me write that underneath, move the 15 together, you'll notice that the equation that we get is the same, let me zoom out a bit, is the same as this one here. Right? It's the same as that one there. Now there's nothing stopping you from timesing at this first line here. There's nothing stopping you from timesing it by minus 4/5 and getting minus 4 for this, minus 4/5 x plus 16 over 5. Absolutely nothing stopping you from doing that. And obviously there's nothing stopping you from this point onwards dividing everything by 5. But sometimes it's easier just to times everything by the denominator, work in that, and then do all your dividing right at the end. It's just easier to deal with it, especially if you're doing it without a calculator. Okay, so that is an example of those ones, of those two different types of formulae, of how to work out the equation of a straight line without using an intercept.